From spaceships investigating outer space to sophisticated robots performing complicated surgeries, it is impossible to imagine any industry, no matter how sophisticated, that does not employ mechanical engineers as dominant and influential members of its staff. Mechanical engineering is an interdisciplinary profession undergoing many and rapid changes, possibly more than any other engineering field today. New developments in the field of system miniaturization and biomechanics pose exciting challenges for mechanical engineers and offer new possibilities for creativity and future research. The Faculty of Mechanical Engineering at the Technion is a breeding ground for Israel's leading engineers who work in research and development industries and hold key positions in high-tech, government, and defense. The Technion Faculty of Mechanical Engineering is a leader in its field. More than 1,200 students study under the instruction of senior academic staff, scientists, and expert lecturers from industry. Students benefit from the faculty's stimulating academic environment and its state-of-the-art laboratories. The research and instruction in these labs, the most advanced of their kind in the world, integrate infrastructural science and the most complex applications at the forefront of technology. The curriculum offers students extensive and comprehensive knowledge of engineering and the major sciences. Major tracks of study in mechanical engineering include dynamics, mechatronics, robotics, mechanics and biomechanics, energy and flows, CAD, manufacturing and control. Professor Moshe Shoam, head of the Medical Robotics Laboratory, has developed a miniature remote-controlled robot that can move independently through the body's channels, veins and arteries, thus facilitating diagnosis and medical treatment without human intervention. Another application developed by Professor Shoam, already in use today, is a miniature robot that performs complicated surgeries on the spinal column, with greater precision than that of a surgeon. This development is already saving lives around the world. Here in Professor Eyal Zussman's lab, structures are developed and manufactured that are 1,000th of the diameter of a human hair and even smaller. This sophisticated system is used to spin miniature electronic fibers that serve as conductors for computer chips and as biological sensors that warn of hazardous substances in the air. Until recently, the word teleportation was mainly known only to science fiction writers. Today, Professor Anat Fisher and her CAD lab research team are developing advanced methods for modeling, simulation, and analysis based on engineering and medical CAD systems. One of these systems enables scanning a three-dimensional object and creating a model, which then serves as a basis for design, computerized analysis, or manufacture by digitally transporting the model to a three-dimensional printer. Dr. van Hout investigates multi-phased flows, in particular to examine environmental problems caused by bioaerosols and particle behavior in a turbulent flow. These phenomena play an important role in industrial and natural processes such as erosion. Understanding how related bodies interact with the flow surrounding them is an important factor in chemical engineering. Research in Dr. David Greenblatt's lab focuses on creating models to demonstrate how objects react under the flow of energy in a wind tunnel and a water tunnel. The flow of energy is controlled in numerous ways, among them electromechanics, voice wave control, and plasma. This research is intended to improve the energy efficiency of equipment such as fans, pumps, and computer cooling systems. Humans have always found inspiration for solving their problems in nature. The same applies to Dr. Alon Wolf's lab, where researchers are studying and investigating how snakes move. We observe and monitor how animals move, particularly the kinetics of this motion. We then attempt to adapt these behaviors into robotic systems, producing robots that try to imitate millions of years of evolution within a mechanical system. These snake robots have many applications, ranging from medical treatments for heart disease to locating casualties during natural disasters. In Dr. Yizar Or's lab, researchers are investigating the dynamics and movement of microscopic swimmers in nature, such as bacteria and sperm cells. Our goal is to develop miniature, micro-scaled robotic swimmers that can be incorporated into mobile human systems, such as the circulatory system, the spinal column, and the digestive system. These swimmers are designed to perform biomedical tasks such as time-release medication administration, transferring camera images, scanning infected areas and tumors, and even performing localized treatments. The device behind me is an enlarged prototype of a technology that will enable us to create energy from slow movement. Researchers in Professor Yitzhar Bucher's dynamics lab are making waves within solids and in the air in order to produce electricity efficiently and transport tiny components and micron-scale swimmers automatically without the touch of human hands. These movements can be hand, foot, or chest movements, or even movements inside the human body, such as the expansion and contraction of the lungs and the beating of the heart. In the future, envelope waves will be capable of moving companies of nanorobots through the human body to target and treat infected areas and ulcers. Imagine a world in which structures such as this one are compressed into a tiny chip measuring 1 square centimeter. Researchers in Dr. Gilad Yosefon's micro and nanofluidic devices laboratory are investigating ways to manufacture and control the movement of fluids. The purpose is actually to take an entire lab and reduce it in size to a miniature scale, and then to be able to make new discoveries about small amounts of fluid, such as a drop of water or a drop of blood. These miniature devices are characterized by micro and nano channels that can precisely filter nanoparticles and biological molecules. The Microsystems Lab is working on developing micro-mechanic devices for special needs, as well as innovative methods for design and simulation. In certain applications, microsystems perform much better than electronic systems, making this innovative technology the focus of much interest. The lab is training human resources to work in Israel's microsystems industry. I graduated in 2003 after completing my BA and MA here in the Faculty of Mechanical Engineering. Today I'm the CEO of a startup company. The chip we manufacture serves as the core of a miniature projector for cellular phones. In Professor Erez Chasman's optical engineering lab, researchers are developing miniature optic components and laser optic mechanic systems for the high-tech industry. The revolutionary technology developed in the Faculty of Mechanical Engineering serves as the basis for building unique opto-nanometric chips. As a result of this extensive research activity, the faculty has developed many close and productive industrial relationships with leading companies in Israel and worldwide. These collaborative relationships facilitate the exchange of research and development knowledge and lay the groundwork for students' future employment. The Faculty of Mechanical Engineering provides excellent tools for setting out on a career as a mechanical engineer. As a systems engineer, I am responsible for seeing the overall picture of an entire project. Through the Faculty of Mechanical Engineering's Brakim program, the IDF trains its future leaders in research and development. The Brakim program is part of the IDF Academic Reserve, and after you complete it, you can be posted in any IDF unit. I, for instance, was posted to the Ordnance Corps where the Merkava tanks are developed. The program provided me a great deal of exposure to military and civilian industries. I studied in the IDF Academic Reserve Program and then joined the Intelligence Corps' Technology Unit. At the Technion, I obtained a broad knowledge base in many fields of engineering and then adapted this knowledge for my specific needs at work. Students in the Brakim program complete their BA and MA degrees within 4 years and then join the armed forces. Since the Faculty of Mechanical Engineering at the Technion was founded in 1935, its more than 8,000 graduates have been major players in Israeli industry, constituting 60% of the country's engineering workforce. The faculty constantly strives to keep up with new technological developments and to add innovative fields to its curriculum. The Faculty of Mechanical Engineering has always been my home. I grew up here, completed my BA, MA, and doctorate here. I decided to follow the academic route and did my postdoctorate in the US. The Faculty of Mechanical Engineering at the Technion is a leader in its field in Israel in terms of the quality of its graduates and its researchers. Therefore, it was clear to me that I would want to return. This striving for excellence, open attitude toward new challenges, and spirit of entrepreneurship, all these ensure the future success and leadership of the Technion's Faculty of Mechanical Engineering. I would be very pleased to have you join the faculty. Together, we can shape the future of engineering in Israel and around the world.